we relying on advanced medical algorithms to guide crucial health decisions every day. But what if the very measurements these algorithms depend on are subtly biased, leading to unfair or inaccurate outcomes for certain groups of people? How does this happen? Measurement bias in algorithmic healthcare happens when the data used to train and operate these systems does not accurately or consistently reflected the real-world experiences or health indicators of all patient groups. It is often caused by inconsistencies in data collection, reliance on imperfect proxy variables, and inherent biases in the tools or methods used to gather information. There are several key culprits that contribute significantly to measurement bias. First, imperfect or varied sensors can introduce considerable bias. For instance, an oximeter, a device measuring blood oxygen saturation, might perform less accurately on individuals with darker skin tones, consistently leading to an underestimation of hypoxemia, which is a low level of oxygen in the blood. If an algorithm then learns from this consistently flawed data, it will perpetuate and amplify this fundamental inaccuracy across all its applications. Second, inconsistent human data collection practices are another major factor. Healthcare providers might record patient symptoms differently based on cultural perceptions, their own unconscious biases, or even the subtle nuances of communication, thereby creating noisy and unequal data. For example, pain scales are subjective tools, and patient responses might be interpreted and reported distinctly across various demographics, leading to skewed algorithmic training. Third, algorithms often relying on what we call proxy variables. These are indirect measures used when direct, ideal data is unavailable or too costly to obtain. For instance, using a patient's zip code as a proxy for their socioeconomic status can inadvertently embed and propagate biases related to race or ethnicity, as residential patterns often correlate with historical discriminatory practices, without ever directly measuring those specific factors. Finally, systemic exclusion in historical training data can fundamentally lead to measurement bias. If certain populations have been historically underrepresented in clinical trials, medical research, or even the aggregated electronic health record systems over decades, the algorithms trained on this imbalanced data will naturally perform worse or generate inaccurate predictions and recommendations for those very groups, creating an ethical dilemma. Addressing this requires a multi-pronged approach. One crucial step is thorough data auditing, meticulously examining datasets for inconsistencies and disparities across different demographic groups. Another involves diversifying data sources, actively seeking out and incorporating data from previously underrepresented populations to ensure a more comprehensive and equitable training foundation. Furthermore, transparent variable selection is key. Understanding why certain variables are chosen as proxies and rigorously testing their fairness across all groups can help prevent hidden biases. Finally, implementing continuous monitoring systems post-deployment allows for the early detection and correction of emerging biases in real-world use. Understanding measurement bias introduces us to the concept of data provenance, which is the detailed record of the origin and history of a data set. Tracing data provenance helps identify exactly where and how biases might have entered the system. It also highlights the importance of algorithmic validity, which refers to how well an algorithm measures what it intends to measure across all populations it serves. These concepts are vital for building trustworthy artificial intelligence in medicine. By diligently identifying and mitigating measurement bias, we move closer to developing algorithmic healthcare solutions that are not only efficient but also equitable and just for every patient. This commitment to fairness in data ensures that technology enhances, rather than hinders, health outcomes for all.